Alright, you are welcome. Today we want to consider double or multiple integral. How to solve multiple integral. Now let's take a look at this question. Evaluate the double integral over the indicated region. The double integral over the region are x squared, y squared plus cos pi x plus sine pi y dA. Then we have r is equal to minus 2 comma minus 1 and 0 comma 1. You get it right? Good. Now let's put it in a proper way. Here we have the region minus 2 comma minus 1 and 0 and 1. Okay, so then we'll take the minus 2 minus 1 to be the x and 0 comma 1 to be the y region, right? So here we're going to have the integral from the region minus 2 to minus 1, which is x, and then also the integral from the boundary 0 to 1, x squared, y squared plus cos pi x plus sine pi y. Then we have dy dx. Okay, so we started with the integral of minus 2 to minus 1 on x, then we end it with dx. Okay, good. Now here we can see that we have inner part of this integral and the outer part. You can take the inner part first and then proceed to the outer part, or you can choose to evaluate the outer part of this integral before evaluating the inner part. Both of them will give you the same result inasmuch you follow the rules. Okay, now in this case I want us to take the outer part first. That is, we integrate with respect to x first before we integrate with respect to y. Okay, now taking the outer part, that means we're going to say the integral over the region 0 to 1, we integrate with respect to x and hold every other variable y constant. Okay, so when we integrate x squared, y squared, we're going to have x cubed, y squared all over 3. And when we integrate cos pi x, we're going to use simple substitution to integrate this cos pi x. When we use simple substitution to integrate this cos pi x, it's going to give us sine pi x all over pi. Then plus, when we integrate this sine pi y with respect to x, we can see that this sine pi y is literally a constant because there is no x. The variable x is not associated with it, and we are integrating with respect to x. So treating this sine pi y as a constant introduces x to it when you integrate it. That means we're going to have x sine pi y. Then we have over the region minus 2 to minus 1 dy. You get it right? So that means we integrated with respect to x, and then the inner part is what is remaining now. So we have the region minus 2 minus 1, or the boundary minus 2 and minus 1. So we are going to place in the upper boundary minus the lower boundary. Okay, anywhere we see x, we'll replace it with the upper boundary minus. Anywhere we see x, we'll replace it with lower boundary. So we're going to have the integral over the region 0 to 1. In this place where we have x cubed, we replace it with minus 1 cubed y squared all over 3 plus sine. In place of x, we replace it with minus 1 pi. Okay, all over pi. So when you say minus 1 times pi, it's going to give you minus pi. Then we have plus. In this place where we have x sine pi y, we replace it with minus 1 sine pi y, all in bracket, minus the lower boundary. So here we have minus 2 cube y squared all over 3 plus sine minus 2 pi all over pi plus minus 2 times sine pi y all in bracket dy. So here we'll have minus 1 cube will give us minus 1. Minus 1 times y squared, we have minus y squared all over 3 plus we have sine minus pi all over pi. Here we have minus 1 times sine pi y give us minus sine pi y in bracket, and then going to the other bracket we have minus 2 cube will give us minus 8. Minus 8 times y squared all over 3. Then we have plus sine minus 2 pi all over pi. And then when you say minus 2 times sine pi y, give you minus 2 sine pi y. Here we have dy. Now, let's open this bracket and rearrange them. You open the bracket and collect the like terms. So when you open the bracket and collect the like terms, you are going to have minus y squared all over 3 plus 8y squared all over 3 plus sine minus pi all over pi minus sine minus 2 pi all over pi minus sine pi y plus 2 sine pi y. Here we have minus y squared all over 3 plus 8y squared all over 3. When you combine this together, it's going to give you 7y squared all over 3. And then in this place, we have sine minus pi all over pi minus sine minus 2 pi all over pi. When you combine this together, it's going to give you 0. It's going to give you 0. Then here we have minus sine pi y plus 2 sine pi y minus sine pi y plus 2 sine pi y. When you combine this together, it's going to give you sine pi y. So here we have the integral over the region 0 to 1, 7y squared all over 3 plus sine pi y in bracket dy. Alright, good. Here let's integrate with respect to y. So when we integrate 7y squared all over 3, what are we going to have? We're going to have 7y cubed all over 3 times 3. You get it right? Good. When we integrate sine pi y, using simple substitution, we're going to have minus cos pi y all over pi. Then we have over the region 0 and 1. You get it right? Good. So let's substitute the upper boundary minus the lower boundary. But before then, let's simplify. Okay, so now let's simplify. We have 7y cubed all over, we say 3 times 3 is going to give you 9 minus cos pi y all over pi. Is that clear? Good. Now let's substitute the upper boundary minus the lower boundary. That is, anyway we'll see y, we'll replace it with the upper boundary in the first time, and then minus the lower boundary. We're going to have 7 open bracket 1 all over 9 minus cos. When y is 1, we have pi cos pi all over pi in bracket minus the lower boundary 7 open bracket 0 all over 9 minus cos. When you say pi times 0, going to give you 0, so we have cos 0 all over pi. Okay, so here we have 7 times y is going to give you 7 all over 9 minus, when you say cos pi is going to give you minus 1, so you have minus 1 all over pi in the bracket. Then we have minus 7 times 0 all over 9 is equal to 0 minus, when you say cos 0 is 1 all over pi. All right, good. So here we have 7 all over 9 minus 1 all over pi is going to give you plus 1 all over pi. Now we have minus. In this bracket, we have 0 minus 1 all over pi is minus 1 all over pi. Then opening the bracket, we have minus times minus 1 all over pi. We give you plus 1 all over pi. So here we have 7 all over 9 plus 1 all over pi plus 1 all over pi. Okay, so when you say 1 all over pi plus 1 all over pi is going to give you 2 all over pi. So here we have 7 all over 9 plus 2 all over pi. So now the double integral over the indicated region we have solved gives us 7 all over 9 plus 2 all over pi. Alright? Yes. Thank you very much for watching. Let's take more examples. Stay blessed.